Hi everyone. It's my pleasure to introduce Marco Gillies, who's visiting us from Goldsmiths University, London. Marco does really interesting work at the intersection of HCI and machine learning, particularly around creative technologies. We met, I guess, a couple years ago when Marco was co-organizing the human-centered machine learning workshop at Chi last year, which was a big success. And so he's here today to talk to us about machine learning for embodied design in virtual reality.
Okay, hi. As Salima said, I'm Marco Gillis. I'm from Goldsmiths, which I've just been explaining, so I won't explain again. Actually, can I have a little bit of input from you guys, just so I know who you are? How many people here are kind of machine learning type people in some broad way? And how many are kind of VR type people? And did anyone not put their hands up? I think everyone put their hands up. Okay, cool. So good. So I will touch on both. Okay. Sorry. Yeah. Okay. Sorry. I what can I do? I can just build better feedback mechanisms. Okay. So what do I do? Well, I do at least some of what I do is stuff like this. So you see here, this is a conversation, as you can see, and there are two people, and then this guy, you can see he's Italian, he's quite, he's gesturing, he's quite sort of expressive, and this guy a little bit less so, which is a shame. We can move on to this photo, and again, this guy, this time he's Israeli, but he's also a very gestural culture, but she is much less graphically interesting than the guy on the last slide, but already there's something going on where it feels a little bit more like a conversation, and that is because she has attached to her a body language generation algorithm, which is a very simple one, sort of kind of equivalent to a level of graphical fidelity, but you can already start, I hope, to read in slightly more of a conversation. And more importantly, if you were this person, this is actually Dr. Daron Friedman, and if this wasn't a fake up, because actually, if you know anything, this is in a cave, and caves are stereo, so you wouldn't be able to take a photo of it. But if this was a real situation, he would, the important thing is not necessarily that she's standing in a particular way or moving in a particular way, but that is responding to what he is doing in the way that we respond to each other in a natural conversation. So I'll come back to and that is the thing I'm interested in, is essentially that simulation of body language that is responsive. And I'll come back to that in a sec, but I want to address a particular question which I've realized I've never talked about in a talk before, but it's really fundamental to what I do. And I think probably if I don't talk about it, people will misunderstand what I'm doing. So there's an obvious question, am I trying to simulate a human? I think that's probably the obvious inference about what I'm trying to do, but I'm actually going to say I'm not going to do that. That's not what I'm trying to do. And I'll do another slight digression into AI and HCI, which I think sort of lots of us work at, around these two kind of areas. But I would say that there's actually something, as well as the technologies, there's actually something fundamental importance. They're both different philosophical positions about what a computer is. And I'm not happy with these next two bits, but AI has something to do with computers as agents, as independent entities in the world, and HCI has something to do with computers as things that fit into human social systems. And I think there's a lot of the time actually the importance of the work is not so much what the technique itself is, but there's actually where do you sit on this kind of among these views of what the technology is doing. And I think sort of actually sort of a lot of the interesting stuff that you guys are doing here is kind of taking machine learning traditionally considered over here and putting it on this side of the diagram. And this is kind of similar to what I'm doing here. So I'm not really interested in the AI question. I'm interested in this character as fitting into a human social system. And in particular, I'm interested in authoring a fictional character as opposed to simulating a human being. Now, what's the difference there? Well, if you think about sort of the archetypical character in fiction, Hamlet, say the importance of Hamlet is not that Hamlet is a full simulation of a human being. In fact, the importance is almost that he isn't, that he leaves space for interpretation. Hamlet would not be an interesting play 500 years later if it could not be reinterpreted within different cultural frameworks century after century after century. And so what I'm saying here is that a fictional character is part of a social system which includes an author and an audience who is interpreting it. And probably most of what I will talk about today is really about the author, in that I'm talking about how does one author a character in virtual reality using a variety of techniques I'll talk about. So that's just my kind of philosophy that I want to explain. I will kind of switch back to the technology, and this is very old work. It was published in 2004, but it was several years before then. And this is kind of my first simulations of interaction. And hopefully you can sort of read into this a conversation. There's no words being spoken, but there are some very simple rules of turn-taking being implemented in here. And there's, sort of you can see that I think you can interpret something into this as being a real conversation. And the characters are deliberately very simple, and I think that helps you sort of accept it. But the rules here are very, very simple, which I'll come to in a second. From that kind of simulation, I moved on to this. You can't really see it very well, but there's where we're taking still a virtual person, but now interacting with a real person. And that interaction is all about, you essentially sensing stuff from the real person, animating stuff from the virtual person, and what I was mostly looking at was stuff in the middle here. How do you trigger animation from sensing? And in my early work, you could work well with some really simple rules. So, for example, for looking at how much you look at somebody, you can say whether they're talking, they're listening, maybe if they're doing neither, and adjust the proportion of gaze they're using to the other person based on all these factors. And that very, very simple state machine model is enough to actually have some pretty impressive effects. I collaborated, now still am collaborated with Pan Shui, also known as Sylvia, on a number of experiments using this kind of model, where she's shown that, for example, up here, anxious men, sort of socially anxious men meeting a virtual woman, had an initial sense of anxiety that they would feel in a social situation, but then would become more socially confident. And in this one, we were looking in detail at the body language. If the body language of the character was confident versus shy, and people responded better to the shy character, we had a measure where at the end, the character would answer a phone call, walk off stage, and say, "Sorry, I'll be back in a minute." And you had a button where you could call her, and we just left the participants to see how long it would take them to press the button, and people took longer with the shy character. So people are responding, and probably responding subconsciously to change not only the body language itself, but changes and variations of the body language, and all with very, very, very simple models.
Body language, the speech itself was the same?
Yes, I would have to check with Sylvia, but I'm pretty sure it's the same. Okay, so this stuff works to a level, but it's first, just intuitively, it doesn't sort of contain all the complexity and nuance that I think all of us believe is there in human social interaction and body language. And, it doesn't, I talked about Hamlet, if you're talking about, say, the famous actor Daniel Day-Lewis performing Hamlet, there's much more than a state machine going on there. But also, I'm talking about authoring this, and how do you author this kind of model to create an interesting character? And to us as computer scientists, that probably looks easy. Oh, I just put numbers in. But how do you get a particular performance effect? And in particular, if you want to replicate the performance of a certain actor, how do you do that? And there's a fundamental big problem here that we do not know, if we're talking about body language, we do not know how we do it. So, all of us are producing body language all the time, sort of implicitly, largely implicitly, but we're not, I'm sure most of you are not thinking about what you're doing, and most of us are not aware of it, and most of us would not be able to say how we use body language. Think for a minute now, over the last sort of 10 minutes or so of me speaking, how much of my time have you been looking at me? How much of the time have you been looking at the screen? I don't think anybody would be able to answer that. You've all just been doing it. And this is because it's, tacit, embodied knowledge. It's things we do implicitly. And this problem becomes, sort of harder, or just as hard if we're talking about, say, getting an actor to perform a character and design a character. Actors are tremendously knowledgeable about body language. That's what they do, in a large sense. But none of that knowledge is explicit in anything like the way we would traditionally want it to sort of put it into a state machine. In particular, it's very much non-verbal knowledge. It's knowledge in the body, if you like. It's not something that an actor can express. I've worked a bit with dancers as well. They often talk and move to express S concepts, or they talk in ways that are, that explain it, but you can really only, interpret what is said if you have experienced something. There's not stuff that is explicit there. So I'm interested in how do you do this design? And I like this quote, which sort of sums some of this up, from Caroline Hummels in the Netherlands. To design movement interfaces, one has to become an expert in movement, not just theoretically by imagination or in paper, but by doing and experiencing while designing. Because the knowledge in movement is embodied, because we know it through moving, not simply in some theoretical or symbolic level, we have to design by moving. And this is something that interested me. So this is what brought me to machine learning. And this is kind of a schematic of that kind of brings together, kind of mashes together sort of a few papers that I wrote, a couple of papers that I wrote. There's kind of several versions of this. But the essential thing is here, we are designing two-person interactions by capturing two people in a conversation. This is how we design it, and then we record some stuff, some motion capture, some audio or some other signals, put it through. I won't talk about, there were several different iterations with different machine learning algorithms and an animation system, but I can go into in more detail if you like. But the key thing is, all this is coming as a design process from starting from a two-person conversation and using that as the means of designing the virtual character. And, so we've... skeletal motion capture for the character, and then for the equivalent of the player... sorry, why is this not playing?
In conversation, people are constantly responding to each other with non-verbal
So for the player, it was head tracking and voice. So there are a few different iterations of this. So this is mostly on voice.
Listeners may well become bored. They would show this boredom.
And this is kind of a very simple system. I'm actually just using variants of the audio signal of the fundamental frequency. But yeah, I'm getting... so
we present
so
a
the,
data-driven
this is the audio we're hearing.
that enables animated characters.
He's responding to... that's a bit ambiguous, yeah. It's me talking to him, so he's a listener. So he's doing what you're doing. And so he's basically responding to that audio signal.
Is central to human social interaction.
So,
Present a data-driven
so this is quite fun. This is nice. This is kind of proof of concept. But creating it was horrendous. Like it was, really took me, hours, years of debugging, sort of when I was learning machine learning at the time, which didn't help. But, there was, I think sort of most of us who've worked with machine learning realize that there's, there is an enormous potential in the fact that you can design through examples. But also there's enormous difficulties in getting it to work in practice. And this is kind of where I came to realize that this, actually it's an HCI problem. This isn't a technology problem. The machine learning algorithms are there. I mean, they're probably much more there now than they were at the time. But really, there's an HCI problem of VR, and that's about the time I encountered Rebecca Fiebrink's work. Does everyone here know Rebecca? I know she's been here for a while. So I'll just briefly say, Rebecca is the developer of the Wekinator, which is a machine learning platform that makes it easy for primarily electronic musicians to design primarily gestural interfaces to the music, gestural musical instruments. And this was a sentence I found really interesting in her thesis. This is a quote from one of her participants. The Wekinator emphasizes an embodied approach to composition by allowing the user to generate training examples by actually performing gestures in real time as opposed to approaching the mapping process rationally or mathematically as is required in the design of explicit mapping functions. So this is this is what I was looking for, is this embodied design approach. And we're very lucky to have Rebecca now at Goldsmiths, so we're working together.
I'm still trying to wrap my head around
Sure.
the previous slide where you were treating kind of the body language as a machine learning problem.
Yes.
And what's confusing me a little bit is the notion of ground truth. So I'm sort of used to machine learning problems where, given a set of inputs, there is kind of an output that you're looking for, right? This picture is a dog or not a dog, right? There's a ground truth to it. Whereas there's a lot of individuality to human response, right? My body language for boredom is going to differ slightly conversation to conversation, much less person to person, right? So I'm kind of, how do you think about labeling and...
Okay, so on that particular issue, this comes back to this idea of authoring a character, right? I'm not trying to build a general body language that is, that it goes across anybody. I'm trying to design a specific character. And what that means is that it's actually even more constrained than a specific person, because if in film or theatre, an actor will have a very specific way of performing a particular character that is unique to that character and expressive of that character. So typically in theatre, it's all about kind of stripping out the sort of the extraneous stuff and just capturing the character. So there is actually, actors will reduce down the variability of what they do. So I'm very specifically saying this is you do at least some of this one-off for each character. And maybe I'll talk a little bit at the end, but actually there's stuff you can do where you start with a platform of quite general learning, but you sort of specialize it. In terms of ground truth, what we're really learning is a mapping function between this and this. So we're learning a mapping function between input signals and movements. And in this context, the movements, what goes into here is we're actually just taking the motion data and slicing it up into little bits and putting it into a data structure that makes it easy to transition from one bit to another. So what this is really doing is, based on these input signals, you're classifying the various clips that you have available to you and selecting one based on that classification. Well, it's a probability distribution, but
like a response.
a clip is a possible
input.
response. It's a small bit of motion capture that I could be doing in response to what's happening here.
Does it do any reasonable job? I mean, if you compare a clip that you only got, say, the audio input, does it generate body motion which is close to what that person did in the clip?
Yes, I mean, at the moment, it kind of, this version is quite discretized. So there was kind of two levels of interest in the clip I did, and most of it works with fairly, discretized classification of input signals. I'm hoping, and I will talk about making it less discretized later on.
So maybe it's not that you want to compare against what the real person did. Maybe measuring performance is about how realistic the motion is. Whether or not the original person did the same response, maybe one way you evaluate is like, is this a reasonable reaction to this input? Like, and have
I mean, if you capture enough data, you'll have lots of reactions which are in some ways socially equivalent but different from each other, in their fine details, which is kind of part of the problem of doing this. But then, part of the problem is you can't say in this context, this one clip is the right or the wrong answer, because they could have been doing something different, but actually which would have had a similar meaning. So so you can do kind of ground truth on here, saying if it correctly classifies, unseen clips, and based on the input signals, if you take a clip and its input signal, and then we didn't do this, and then you shuffle them, does it give, does it find the right, does it classify the correct one higher than the incorrect one? You could do all of that training, but there are, once you can validate the classification problem in that way, it becomes a bit harder when you're validating the entire system, because there are many things it could have been doing, which is where you would normally go back to the kind of human studies that I did with Sylvia. We didn't get around to doing it on this system, unfortunately. Sorry, any other questions, or I'll move on? Yep.
I was a little late, and I think I missed the beginning, sorry. So this is an agent that you're trying to have react to other agents through body language?
To react to people.
Okay, and it's trained by the body language of the agents around it?
It's trained by a data set consisting of both sides of a two-person conversation. So you're capturing data from, if the two of us were speaking...
from two humans, okay.
From two humans originally.
I see.
And, if you want to replace me with a virtual character, I would capture data from you, I would capture data from me, I would use the data from me as motion cap to go into an animation engine, I would capture data from you to go into a machine learning system to classify what you're doing.
Particular reactions as a performance, but generalized in a way that it's autonomous. Okay.
So, the setup would be you would have, you'd probably capture a single performer multiple times interacting with, for the character, a single performer responding to a wide variety of sort of other people, members of the public, audience members. So we didn't have time to capture enough data for that, but we did do that in a later project that I'll show you. So what this all led me to was that, okay, I shouldn't be doing, it shouldn't be me doing this classification. I should be working with an artist. So I worked with, this is Emanuele Nardi, a physical actor and performer. And we got him, we built a different system. This is actually several years later, and where he would interact with a member of the public, the guy in the purple shirt, and they would improvise sort of interactions together. This was his practice was very improvisational, and we would use that to train a classifier. So, and actually, I just got to a bit, and we kind of gave it all to him. So he was working with the sort of the system which was actually generating the classification. So we didn't have any input. We showed it to him. So in short, actor in a mocap suit, sort of audience member of the public in front of a Connect. It was a Connect 1 in those days, interacting via a virtual character. And it was, in some ways successful. Technically, it's quite easy to learn. You can learn it fast. All the people that came in after a few seconds, everybody was able to add clips, add classes. So this is the actor speaking. He worked with a number of other members of the public. So, the idea of machine learning and tagging up clips was not difficult, but about 60% of the time it did what I wanted to do. The other 40% time of it was insulted. Okay, so it didn't work perfectly the first time. We know that is the likely outcome. But the problem is he didn't know, at that point he didn't know what to do. About the clips, I'm still not clear what the problem is. So the biggest problem in this kind of first iteration of the system was how, fine process, but when it goes wrong, how do you debug it? How do you know what the problem is? And I'm sure this is something that you all have encountered in your own work. Because, we're working with very opaque systems. And what I found useful at this point, and this is a system, a framework developed by Anne Blanford at UCL in London, called CHASM, the Concept-Based Analysis of Surface and Structural Misfits. Because I thought what was quite interesting is that there's this works on concepts that exist in a computer system versus the user of that computer system. So the user has some conceptual model of what's going on. There is some conceptual model embodied in the interface of this computer system, and there's a conceptual model embodied in the actual system itself, in the code. And these don't necessarily match. I mean, even here, these two don't necessarily match. But I think it's quite an interesting framework because then you can start to map out what is going on. And there's three things that can happen. One is that a concept can be present. A concept can be absent. That concept doesn't exist. Or a concept can be difficult. So, it kind of is there, but it's not, it's either not there in kind of on a first order or it's hard to use in some way. So we map this out, and there's various bits, but the big thing is that the things that the actor was talking about was actions and responses. So I do this, the character does something else. So the action was like the key thing. So and that's present in the user. That's what the actor was talking about. It wasn't present at all in the actual machine learning system. It was kind of there in a sort of slightly indirect way in the user interface, but actually it mapped to something that was not a first order feature of the actual classifier we were using, which was a decision tree.
When you gave as an input the skeleton, it didn't use the motion and the action as a...
Well, it was using. Okay, I'll come to this line. Okay, the features. So what it did work on is a decision tree. So everyone's probably familiar with a decision tree. But what a decision tree does is it picks individual features, and in this case, an example of an individual feature is the kind of the Y rotation of the right shoulder, and it kind of splits, makes a split decision on that. So it'll say, okay, let's look at the Y rotation of the right shoulder. You know, is it more than this? Okay, I'll go down this route. I think it's, you know, it doesn't make a decision on a single feature, but then it looks at other features. If it or it goes the other direction and looks at other features. But this is the core thing it's working on. But this wasn't really represented in a sensible way in the system, and it's not something, you know, you could talk about the shoulder rotation to the actor, but it's not the way he was thinking. It's not how we normally think about machine learning. So it's very about body movement. So what it's doing here is it's very much breaking it down, whereas here what I'm talking about is we were thinking about movement in a holistic way. So we're not thinking about it of breaking it up into individual body parts, you know, or even finer than that. We're thinking about holistic movements. And so, you know, this is a kind of representation of a decision tree. Is the left shoulder X this? Well, otherwise check the neck, otherwise check the right wrist, and then you make a decision as to what it is. So this is not sort of the way people are thinking. So we switched, actually, let's use a classifier that works with holistic poses. So we kind of used a smooth, kind of a soft least squares, soft nearest neighbor approach. So we were looking at all the nearest. So we take, take the new pose, compare it to all the existing poses, and essentially produce a score based on a weighted sum of the existing poses, you know, weighted by how similar or different they are to the new pose. And what's nice about this is that you're working with bits of the original data set. So you can, with this, you're working holistically, you're looking at a whole pose, but you can show this to people, you can visualize what's going on in the algorithm simply by showing individual examples of it. And then, you know, actors can come here and say, so you can show a visualization like this. This one, I think it's the yellow class because it's very similar to this one. And we did some small scale studies. Unfortunately, we ran out of money to do bigger studies, but people were really able to use this and understand, oh, okay, so it's doing the wrong thing because it thinks it's like this thing. I need to add some more data or even remove some of the data items.
So did you compare like the performance of both of these, or are you talking about the debuggability? Like, so this was just more debuggable than the other technique.
Yeah. So in this context, in many ways, debuggability equals performance because if you can't debug it, then you can't really make it perform well. But yeah, I mean, there's a lot more to do in terms of, you know, sort of how to measure. What I didn't do in this project is measure sort of on any traditional measure of machine learning how accurate it is. And there's an interesting question of how you combine kind of human-centered and sort of accuracy measures. Sorry.
But, so even in debugging, so step one is figuring out that there is this problem, but like, would this lead to some action? Like, how does this lead to some action that the user could take to actually improve the system? Is it to give a different example input?
Yeah.
And as in the decision tree.
In both contexts, their response would be to either delete a particular example or add new examples. But with this example, they they were more, they could figure out how to do this. I mean, again, this is a small qualitative study. We didn't do a full evaluation, unfortunately. Did you have another question?
Yeah, so you've changed your learning to match this then.
Yeah.
But you also take, you take some history into account also during the learning? Or do you just do it pose-based? Like you look at the...
No, it's poses plus velocities, actually, which we're not visualizing here, which is another problem. I have worked with like hidden Markov models which do history, but actually for very free-form movement, it can be actually it's hard to sort of use a history-based model, because then you'd there's not a single set of steps of where you can go from here to here. Your people. Whereas I think having pose with a bit of movement is actually quite a nice feature here, because if somebody's doing a very definite gesture, right? So if I'm doing this, then a HMM is the best thing to do. But if I'm kind of doing this and I'm going from here to here, there's not a standard accepted sequence. So I think you're kind of better off just looking where you are now and maybe sort of how you're moving as opposed to sort of history. I flip-flop between these. I may go back to sort of temporal models at some point. Okay, so I will do a final digression, I think, just because I like the name machine teaching, and I'm going to kind of reflect a little bit on some of the thinking I've been doing about the relationship between machine learning and human learning and teaching. So, as I was saying at the beginning, I work at Goldsmiths. It's a university very famous for the arts and design, my teaching of computing has been very influenced by art and design teaching, and one of the books people I've been very influenced by is Donald Schoen, who's author of the Reflective Practitioner, who has got this idea of the reflective practicum, which is essentially a studio-based teaching environment, but he applies it not simply to design, but sort of many areas of professional practice, including, I think he talked about urban planning and law and psychotherapy. And the idea is that you have this kind of one-to-one sort of counseling and coaching that goes on. And actually, this goes on in computer science as well. If you're teaching somebody to program, at a certain point, you need to sit down with them, and they've got a problem, and talk it through with them. And there's lots of kind of complicated things that go on here. So at the most basic level, mostly computer scientists here, if I talk of this in terms of programming, it'll probably make most sense. So, and that's what I teach, so it makes most sense to me. So I'll demonstrate. So I'll say, okay, this is, you want balls to bounce around, you give them all a velocity, and I may even type on my screen, and they'll see what I do. Then the student goes away and scratches their head and tries to do something. They act, and I see that and feed it back. And in some ways, this is kind of the basic, like the basic machine learning cycle. I give examples and then I act. But then there's a lot going on. I could sort of give meta explanation of what I'm doing. And I would certainly give some feedback about what they're doing. So say, okay, that's great what you've done, but I think you should actually do it this way. Or, oh, I see you've got a problem. Have you tried doing this? So there's kind of a lot of implicit teaching going on and a degree of explicit teaching going on. But there's a problem with the explicit teaching, which is that when you have an expert in a field, they understand so much of the tacit knowledge of that field. And, they'll be able to say things, they'll talk in a way that is not very accessible to people outside the field. And in particular, is not accessible to a starting off student. So if I go to a programming student and say, that's nice, but this is a more elegant solution, they will literally have no idea what I'm talking about. You know, they don't know what an elegant solution is. They don't have a way of interpreting it at the beginning. And part of their learning is gradually understanding what I'm talking about. And I can't really tell them that. There's lots of stuff I can tell them. I can tell them what an if statement is. I can tell them, you know, sort of what a for loop is. But I can't really tell them how to start with a problem and write a program. They have to do that through acting, through actually doing it, and also through interpreting my often quite cryptic, and I try, you know, obviously try not to be cryptic, but to a beginning student, I will be cryptic comments about sort of the different ways of writing a program and how good or bad it is. And this is computer science. If you transpose this into design or fine arts, you can see that the gap is maybe wider, and certainly the amount of stuff that is tacit and impossible to put into words becomes much, much bigger. So what is going on all the time is that both teachers and students are reflecting on and trying to understand what the other person is thinking and trying to do. And at least if you have a good teacher and a good student, they're trying to interpret it, but they're having trouble. There's this kind of fundamental gap that goes on. And so this has to cycle a lot, and this is what he calls a cycle of reflection, sort of action, feedback, misunderstanding, reflection, trying to sort of bridge that gap. And I think, you know, my thoughts is that something quite similar is going on when we're talking about sort of machine teaching, is that we've got this basic cycle going on in terms of, you know, sort of, I give examples, I test, I see, but actually there's a lot of space for more explicit input, and obviously the machine learner learns, but also what I've been doing is the need for feedback to the designer, because there is this basic gap of understanding between, you know, the designer and the machine, and the more sort of explicit channels you have about what the other is doing, the easier it is to sort of shorten that gap and gain an understanding by which the designer can reflect on what's going on and then try to sort of repair and do something better. So that's just a bit amusing, I guess. Anyway, I'm kind of near the end. I'll throw in a couple of things that are happening at the moment in case of interest. So a lot of this stuff is, I've kind of given you a big picture, but lots of this stuff is actually quite separable, and I'm doing various projects which are related to what I'm doing, but you know, not necessarily the full picture. So one is, this is not my project. Actually, Rebecca's involved in this. It's a project called Rapid Mix, which is building a kind of next generation version of the Wekinator aimed at kind of getting it out into industry and supporting SMEs. But they produced this library, RapidLib. The reason I'm mentioning it here is that I've taken that and ported it to Unity, so that we should, in, you know, the next 6 months or so, have a nice interactive machine learning platform for VR. And, you know, I will want to use it to do some of the things I'm talking about here in terms of social VR, but actually there's a lot you can do in terms of simply VR interaction. So VR, because it's so embodied, you want to interact with it as per the real world. So having sort of more movement-based interactions is going to be really powerful, and it's the kind of stuff that is going to be very hard to do explicitly. So I was talking to a guy who's doing a fencing simulator, and, you know, you have to judge whether you're doing this in the way. I can't fence, so I don't know what is right or wrong, but you know, this is not something that's very easy to code explicitly, but some machine learning would be very helpful. At the other end of the scale, I've got a project with Antonia Hamilton at UCL, which started a couple of months ago, where we're capturing a large data set of two-person conversations with mocap, eye tracking, audio, all sorts of sensors. And we're going to try and really look to get to the bottom of what what actually is going on in a two-person conversation. How much are we actually responding to each other, and what are those responses and coordinations? Because there's a lot we simply don't know. Antonia's a social neuroscientist. That field, we can't go to them yet because they don't know. So we're going to work on that together with the eventual aim of building a virtual character, eventual aim of doing the thing I said I wanted to do on the first slide. Again, this has less of the interactive side of it. And then Rebecca and I have just had a proposal accepted to edit a book on human-centered machine learning. And if anyone wants to contribute, we would much appreciate it. So we want to have a kind of reader handbook that surveys sort of work in sort of, well, human-centered machine learning, the HCI of machine learning very generally. I know that's what a lot of you guys are working on. So yeah, that's me. Any questions?
Could you go back to this where you touched? Oh,
The slide with the feedback.
yeah, the feedback.
If you have more.
The humans or the machines?
Well, no, this one. So one way of giving explicit input is through the features.
Yeah.
Right? So examples, you demonstrate things, but you can explain through features. And is that something that you're exploring?
So you mean feature selection? Or
not necessarily feature selection, but like look at, when I'm moving my arm this way instead of this way, having the user tell the system what features to use. So instead of having you're limiting the set of features based on whatever sensors you've applied, right? But if the user can help say, actually, it's probably better if you look at
so sort
if
of
I place a sensor here. So that's like having
kind of a human-centered feature selection. Feature selection in a.
I would say feature generation, maybe. Feature selection, I think, assumes you have a larger set of features available, and you're trying to narrow it. But maybe the user can express a new feature based on by communicating with you, right?
Okay, so you're almost kind of training a feature, and then demonstrating a feature, and then using that feature to demonstrate higher level concepts, that kind of thing.
Sure.
Yeah.
It's like instead of just by example, showing you that this is how I react when you say something, look at or listen to the tone of my voice. That would be maybe a feature. Listen to subtle things that you can translate from what the user's saying into a feature, right?
Yeah.
It's another way of sort of getting that explicit input, right? And so I'm curious just to know if you're exploring that in any of your work, or you said the interactive VR stuff that Rebecca was doing, is featuring enabling people to provide features. Is that something?
Rebecca's done something in that area, I think.
Yeah.
So I think she's done something about sort of feature selection. I haven't personally. I think it's an interesting area. Just kind of what I didn't mention, and I probably should have when I was talking about this stuff of stuff being present or absent, and sort of these features being inappropriate. This is very, very domain dependent, right? Because we're talking about actors, we're talking about poses. Actually, if we're talking about text, features which would be words might be exactly the right thing you want to look at. And holistic sentences might not be, So yes, I think sort of looking at picking out some meta way of doing this, where you're picking out what the interesting high-level concepts are, could be really interesting. But I'm a long way from doing that.
Can you show the diagram again with the cycle?
Yes.
The question I have is, in your experience from tools and seeing things in the field, what is the right test or metric to decide that you're done? You're done teaching, you're done training, and it's time to use it? Or is this, you're trapped into this cycle forever, and
in terms of humans, it's very hard to know. In terms of machines, if you know exactly what you're trying to teach, if you've got a fixed kind of concept, that's fine. But a lot of what we're doing, the concept isn't necessarily that fixed. It evolves.
Well, in your personal experience, you say you've been training, you try to train something, and you find out, aha, I know I'm done. Can you share with us how did you reach that conclusion?
I think it's very much like software development. I think you sort of you test and test, and you hit a point where it's succeeding at most of the tests you're giving it. But just like software development, you will the more you test, the more stuff will come out. So, I'm testing it as a research prototype. I will test for several days, and it will kind of converge and be giving mostly the right answers within a small group of people. I'm sure, and that's how I would do if I was explicitly coding a research prototype. I'm sure kind of the engineering guys over there who are shipping, Word or whatever, they test an enormous amount more than I do. And, I think that then there is, I think you just have to, if you're kind of shipping something, you have to go through a very, very rigorous testing process because, the big risk with machine learning is that you, just like when you have in traditional software development, if you don't run enough of the right test, or if you're missing a test here, you might be missing some bit of data set which is actually really important to you. So like the classic examples of a data set of entirely white people for face recognition or something, but probably something more subtle than that. So I think there's I think you have to expand your test data, which in this case means the people using your system. So having people interact and test with it.
Is this cycle, is it more like single example oriented, or is it more of a set of examples?
I think you'd probably start with a bunch of examples, and then you might, as you refine, you might get down to individual examples. As you refine, actually, I just need this example. In general, this is kind of talking about, interactive machine learning. The data sets will be much smaller than if you were doing batch learning. But yeah, I think typically you'd work with small batches of examples. So you'd come in and I think this is what my users were doing. They wouldn't come in and say just one particular pose, but they would, okay, it's missing in this area. Let's do a few of this area. Maybe
Multiple examples from a single class.
Yeah, so a single area of kind of feature space. So once this is after you've done the first set of examples. So you kind of bootstrap it by saying, these are the various classes I want, and then you say, then you come in and say, actually, it's not really getting, I can do like a stupid one. Hey, all my waving examples are with my right hand. I better do some with my left hand. So you would fill in a bit of features of the data space with new example, a bunch of new examples in that area. That's typically what would happen.
All right, so the questions.
Okay, thank you.